Okay, for this problem, we are going to have to first of all figure out what ordered pair it is that we see with the dot right here, or the point there. So I'm going to zoom in a little bit and kind of try and figure out what ordered pair this is. I can certainly tell that it is 3 comma something because of the x value here. The problem is, what value is that right there? Well, right above it is 2,000, and we can see that it's divided up differently than sometimes what we see. This means that the scaling on the vertical axis is a little bit different. And to me, it looks like it's probably going by 500s here. So in other words, the first value here is 500. This is 1,000, and I'm having to really squeeze this in here. So it looks like that's 1,500. So it goes 500, 1,000, 1,500, 2,000. So that means the ordered pair that is here is 3 comma 1,500. So now let me go ahead and zoom back and write that ordered pair down again. So the ordered pair that is plotted there is 3 comma, and I think I maybe said 15,000 before. I meant 3 comma 1,500. So now that we know what that pair is, let's just go ahead and find the unit rate. Remember, the unit rate can be found by, or even the constant of proportionality, depending on how you want to think about that, by taking the y value and dividing it by the x value. And remember, when we have whole numbers, we'll just set it up as a fraction and then reduce. So when we reduce, we get 500. So the constant of proportionality is 500. And the unit rate, we know that 500 will be part of it. And now we have to look at the y-axis first, or the vertical axis. And that represents gallons. So we've got 500 gallons per what's going on in the x-axis, which is hours in operation, so that would be per hour. Now, once we have that information, we should be able to answer these true or false questions. So the first one says the visible point on the graph represents the number of gallons of water used when the factory is in operation 3 hours. Well, clearly, that is what is happening right here, 3 hours. So we know that this one will be true. The second one, the factory uses 1,500 gallons of water when it is in operation for 3 hours. Well, we already knew 3 hours, and we already figured out that that was 1,500. So this one is also true. Now, what's going to happen when you get these types of problems is sometimes the first one is true or false, sometimes the second one is true or false, and sometimes the third question is also true or false. So you have to actually check them. The last question says the factory uses 13,500 gallons of water when it is in operation for 9 hours. So what we could do here is we could relate this back to the times that we do tables. So if the unit rate is 500 gallons per hour, that means for 1 hour, the number of gallons used was 500. We also know that the plotted point is 3 hours and 1,500 gallons. The question is this true or false? That's the question. So we can go way back to scale factor, and we could use the multiplier this way, 500, 500, and see if that is a true statement. So, I know I got a lot of work up here. Well, we can clearly see that 9 times 500 is not 4,500, so the last one has to be false. So this is how you do a problem like this one. Now I'm going to go through a couple of others here on this video. Okay, so this problem is extremely similar to the last one. it looks like it's probably a little bit easier to find the constant of proportionality, but let's look at the point that is plotted there. This point is at 5, 40. So remember, take the y values, divide by the x values. 40 over 5 simplifies to 8. So we know that k is equal to 8. In other words, the constant of proportionality is 8. We know that the unit rate is 8 something per something. So now we look at the y-axis. So this is $8 per hour. So there is our unit rate. So now that we have that information, we can start answering the question. So the visible point on the graph represents a total cost of electricity when operating the business for 40 hours. Well, that's not true. This right here is 5 hours. So this question would have to be false. And once again, sometimes these are true, sometimes they are false. Another point on the graph, and I think right now I'm going to erase some of this stuff that I have here. All right, so another point on the graph that could represent the total cost of electricity for $3 when operating the business for 24 hours. So what I'm going to do is I'm going to put the unit rate here, which is if it's $8 per hour, then that means that for 1 hour, the cost is $8. And I know I didn't do this in the first one, but probably should have put the labels up here. That's dollars. So the question is, if you had 24 hours, would the amount be $3? And clearly, that's going to be false because the multiplier here is 8. And when you multiply 24 times 8, the answer is not going to be 3. Okay, so this one is false also. And the last one, the total cost of electricity for $8. The total cost of electricity is $8 when operating the business for 1 hour. And that's basically what's going on right here or right here. So that one would be true. Okay? So if you got that problem, that's what is going on with this type of problem. And then now I'm going to go ahead and do the third type. All right, so while all three of these problems have different scenarios, the idea behind what you're doing is exactly the same. So I'm going to start with the ordered pair that we can visibly see here. So that is 4, 320. And so we're going to start by finding the constant of proportionality, which is easiest to find by taking y and dividing by x. So we've got 320 divided by 4, which is 8. So that means the constant of proportionality is 8. And the unit rate is 8 something per something. So we'll go back to the axes here. So we've got, looks like the number of cakes. So that would be cakes per minute. So cakes per minute is the unit rate. And I may or may not need a table at this point, but I'm going to go ahead and start a table just in case we need it. All right, so let's look at the first question here. Point P represents the total number of cakes packed in 320 minutes. Well, this is minutes. We can see that that's 4 minutes, not 320 minutes. So this one is false. And just like the other two, sometimes the question is true, sometimes it is false. The number of cakes packed in 8 minutes. So this is the minutes column, and this is the number of cakes column. So the question is, if the time is 8 minutes, the number of cakes is supposedly 720. Well, the multiplier here is 8, And last time I checked, 8 times 8 is not 720, so this one is also false. And then we will look at this one. The number of cakes packed in 1 minute is 80. Well, that's not true. 1 minute is 8. So in this particular problem, they all happen to be false. So when you get this type of problem in the homework, this is what you will do. And that is it for this type of problem.